In this video, I'm going to show you how source control isn't just for developers, but actually useful to admins, in a session entitled Git for Admins. So, as an admin, why do I actually need source control? Well, for a start, it's a good way to keep your changes safe. You have a backup of not just your data, but of your config and your code if you have that from your developers, and pretty much every piece of setup with a few corner exceptions from your entire org. Additionally, you have an audit trail of those changes. Who made the change, when they made the change, and if they're actually behaving themselves and adding suitable comments, why they made that change too. And finally, and for some most importantly, it allows you to share changes easily between environments. You can actually move those changes from sandbox to sandbox and into production and beyond. And it's an alternative for having to work with change sets which have a few little quirks that can be frustrating from time to time. So what is this Git that we talk about, and why does it have that crazy name? Well, Git was actually created by a chap called Linus Torvalds, who created the Linux operating system. And with his typical self-deprecating humour, he claims that Git is named after himself. But in reality, it's a distributed version control system. Distributed meaning that it can be spread out across multiple instances, and it tracks the changes in source code during your software development, because development isn't just about code, as we all know. We can also track changes in any set of files, and this is kind of where it becomes useful to admins, as we'll see in a moment. Because with Salesforce metadata, everything is a file. Now, if you're unfamiliar with the concept of metadata, many people talk about it being data about data, but in practice it's a descriptive way of detailing your configuration changes, be they flows, workflows, they can be code and triggers equally. It'll be your report types, it'll be your page layouts, your objects and fields, pretty much anything that you can define in Salesforce can be extracted out into metadata, and being metadata, it can be extracted out into a file and put through source control. So here's the time to see how that works in practice. If we just flip over to there. So for this demo I'm going to be using Visual Studio Code, and the reason for this, it has a vast array of powerful tools for all types of editing of files. Despite the name, it's not just about code, but also the Salesforce CLI, which we'll provide some links for later, is integrated very well with the extension plugins for Visual Studio Code, which means that effectively we have a one-stop shop for working with all things Salesforce, which hopefully we'll be able to demonstrate. So the first port of call is to create a new project for Salesforce in Visual Studio Code. I'm working on Windows here. Your shortcuts may vary a little on a Mac, but Control-Shift-P, which I believe is Command-Shift-P on a Mac, will bring up the command palette, and from there we're going to check Create Project with Manifest. Now it's important at this stage that we choose the manifest. This will allow us to select which elements of metadata we want to bring out. So we're going to create that one. We're going to give the project a name, and I'm going to call that Git For Admins. And we're going to park it somewhere. And after a short delay, that'll create the skeleton of a Salesforce project. Like so. So a very quick walk through what we're seeing here. This is the list of files that are contained within our local, i.e. on my laptop, project. The manifest that we talked about earlier is in the obviously named manifest folder, and it's contained in a file called package.xml, which we'll look at shortly. The majority of your Salesforce metadata is in this Force app project, and you can see here I've got some skeleton folders based on the fact that the default manifest creates placeholders for much of these files. If we look at the manifest, we can see here, if if I move this out of the way, we've effectively got an XML file. Now don't let that put you off. It does look a little bit codey, but it's very easy to interpret, I'll show you. So within that structure, we have a selection of these types tags, like so. Within each of those types tags, we have two subtags. One is members, which specifies what items of that type we'd like to select, and the other is the name class, the name tag, that specifies what type of metadata we're pulling out. So looking at this first one, we have a star, which means everything. It's a wildcard like you'd use in files, and we have a name of Apex class. So basically what we're saying in this particular tag in the manifest is bring me all Apex classes. And we can see equivalent tags for all Apex components, Apex pages, all that lovely code stuff prefixed by Apex there. What we're going to do here is we're going to bring an additional tag in, and we're going to bring out some of our configuration data. So I would recommend opening and closing your tags at the same time so that you don't forget. So we have a types and a /types. Then within that we have members. Now we could do a star here and select everything. In this particular instance I want to have account, so again a closing tag with a / like so, and I'm also going to type contacts. Now you notice that I'm using the singular rather than the plural here for accounts and contacts. It's because we're specifying the name of the object. So within the Salesforce system, it's an account object, a contact object, and then I am just filling that with what type of information we want here. Now here's a little gotcha which will be useful to note down. Even though those are standard objects, within the metadata when we're pulling them out, they still come under the heading of custom object. I'm sure there's an underlying reason for that. I don't know what it is, but rest assured any object that we want to pull out, be it custom or standard object, is going to come in that custom object tag. So basically what we've done here is, if we look over here, we can see within the objects, when I click on that to expand, there's nothing in there. Okay, I can see that over here. I've now added that to my manifest, which I shall save, very important. Okay, so we now have a manifest that specifies what we'd like to pull from our Salesforce instance. The next thing we need to do is tell it which Salesforce instance to use. And for this, we're going to say authorize an org. Now at the time that I last checked this, connecting to a standard org, i.e. a sandbox or theoretically to production or a developer instance, basically anything that isn't a Salesforce DX Scratch org, was listed as a beta feature. But that said, it seems to be rock solid. I've used it extensively. I hope that it'll come a general available feature pretty soon. So I'm going to log into production here. It's not a real production instance. This is a developer edition that I stood up for the purposes of this demo, and developer editions work under login.salesforce.com rather than test. So I'm going to click on that. I'm going to give it an alias. Now an alias is like a shortcut so that you can easily remember which orgs are. So I'm going to call it Git Demo. Okay. Now you'll notice here it's fired up Salesforce. It's asking me to log in. Okay. This is one that I use for my Maidstone admins group, hence the name. So I shall log into that to authorize that org. Like so. So already we can see there's a natural connection between the Visual Studio Code and its plugins and your Salesforce instance. There, we've logged in. Now if we flip back to our editor, we can see there, down here, authorize an org successfully ran. And we can see here We set the alias to Git demo, and we've logged into Salesforce production, and we're successfully authorized. We can additionally see that down the bottom here, where we can see which org we're authenticated against. Okay, so we're now connected to our org. We've now told the manifest which items we want to pull from our org. It's now time to actually do that pull. Now, there's a couple of ways we can do this. What I like to do, and you're not obligated to do it this way, but I find that package XML file, I right click on it, and in the commands at the bottom I can see retrieve source in the manifest from the org. Exactly what we want to do here. And away it scurries to go and do that for us. Hopefully a little quickly. And there we go. It's pulled out a whole bunch of information. So if we scroll back up and have a quick look. So there's an Apex page in there because our manifest here contains Apex pages. There's the account custom object, the fields contained within those objects, and scrolling a little more, the same story for contacts. We've also got a list view on there and a web link, and pretty much the basic definition of our objects there. So that's completed. So now if we go back over here under our Force app main default, it's the Salesforce DX structure, but we're still not necessarily using DX scratch orgs. It's just the project structure. But if we go to our objects now, and excellent, nothing's happening. Oh, the joys of a live demo. Let's just hit the refresh button. There we go. There we go. Everything's better with a refresh. So, within our objects we have our account and we have our contact. If we drill down into those, we can see the fields, the list views and the web links are split out separately. This is going to be very useful shortly. So each of our fields is its own file. Now this is different to what you may have seen before with other tools such as the Force.com IDE or using Ant packages, where you would get the old metadata format, as it was called, in which the entire account object was one big monolithic XML file. Here things are broken up in a much more logical structure. Here's our billing address field, nice and small. So if we were to make changes to this, we would only have to work with this small file. Okay, we'll look at some of the customizations later. So at this point, as I say, we now have a copy locally of our Salesforce org, not necessarily all of it, but the items we've defined in our manifest, and now we can actually work to getting that under source control. So bringing up our command palette again, and if we search for Git, we can initialize a repository. So in Git terminology, a repository is basically a silo. It's an instance or where we can actually store our source control. So we want to create a local, i.e. on our laptop, copy of that repository. So we're going to take the current folder, Git For Admins, and we've initialized our repository, just like that. Now the sharper amongst you will have noticed the little icon here has lit up with a number of files, pending changes. Git is actually integrated into Visual Studio Code, which is another strong reason I've directed you to use this tool. If we click onto that, we can see there all of these changes. Now we haven't necessarily changed these from the perspective of the Salesforce org, but they are new to Git. So we have a local instance of Git in this folder, and none of these files have been added to Git as of yet. So we're going to change that. So for the initial commit, we're going to add Stage all changes. Okay, so again, another piece of key Git terminology is staging. Staging means effectively these are the changes or files that we want to add for committing into our source control. So you can effectively think of it like change sets, where you're consecutively adding files and items and things into your change set, and when you upload your change set, that's effectively the equivalent of doing a Git commit. So we're going to stage all changes, and you'll see there that's changed to staged changes. We're going to give it a commit message. Please, please, please always do commit messages. Commit messages allow your additional team members, your other admins and developers, to see not just why and what was checked in, not when and what was checked in, but also why it was checked in. It allows us to give a little context. So in this case, I'm going to use the traditional first message of initial commit, and Control Enter. You can see that all our changes have disappeared. They haven't disappeared in terms of existing on your files. They've disappeared in so much as there is no difference between your local copy of the code and what's checked into your local copy of Git. Okay, they are exactly the same. Now, there's one more step that we need to consider here, and that is, okay, this is all local. How do I safeguard this remotely? Now, for demo purposes here, I have created a remote repository on GitHub. GitHub is a cloud-hosted Git repository used across many systems, not just Salesforce. It's very popular for most use cases. It's free. Other Git providers are available, of course. At work we actually use Bitbucket, but everything tends to work pretty much the same. So this is a empty repository that I created earlier for this demo. The key piece of information we need here is the address of this. So let me zoom that up a little. We can see that this is the address of our remote repository, and we're going to connect that to our local repository. So handy little button at the end copies that to the clipboard, and again our old friend the command palette in Visual Studio Code, git add remote. Okay, so I'm going to give it a name. I'm going to call it GitHub. You can call it whatever you want. That again helps you to remember where you're pushing your code around to. The remote URL we just copied, like so. And there we go. That is now connected. Can't necessarily see it's connected too easily. I'm sure one of these icons, probably this one down here, will tell us. But what we want to do now is what's called a git push. And a git push means move anything that we've committed on our local repository up to our remote repository. And again, command palette is the easiest way to find these things. We're going to do git push. What have I done? These things never go smoothly. Let me try git. Cannot type. This will all be fine in the edit. Push to GitHub. That's looking better. I forgot to tell it where we were pushing it to. Okay. So, again, not a huge amount to see on screen. It's one of the things I'd probably want to see changed. But there was a little progress bar up here which has stopped running now. If we flip back to our Git, zoom back down, refresh the page, there we go. So we see a few things here. We see one commit. We see our code appearing in there. So I can drill down into this and I can find our objects. I can find our account object. I can see the fields in there. All the stuff that we saw locally is now in there. Okay. And if we go back to the top there and look at our one commit, we can see there's our commit message, initial commit. So far so good. Now time to make a change. Go back to our files. I'm going to create a new field on account in our Salesforce org and push it through that process. So back to our Salesforce org and into Object Manager. Bring up the account, fields, and we're going to create a quick dummy field. We shall create a, I guess it doesn't matter too much, we're going to create a text field. And we're going to call it Git name. We're not going to do anything particularly special with this, it's purely for showing how we move those changes around. Next, and save it. So again, this is all on our Salesforce instance at the moment, creating a new field just like any other straightforward admin task. But now we want to actually start moving that around. We can go down to here, we can right click on the account, and we can say retrieve source from org. Okay. We want to get the latest copy of the account object. So you'll notice that we didn't actually use the manifest this time. This time we actually already knew about the account object and we just wanted to pull the latest. And you can see down here, here is our new Git name field. We now have that locally on our hard drive. Okay. Now we need to get that into Git. No, they don't give a shortcut on there. So we go back to our Git tab and refresh. And look, oh, there's a new item that's changed. So again, right click, stage changes. So it's now ready to go into our commit bundle. In this instance, a bundle of 1. The tried and tested Git comment, added new Git name field. And we have now committed that. Now remember, this is only committed locally. Okay, I'm going to show you another way of pushing that to your remote. See down here, we've got the little cloud with an arrow, i.e. pushes up to a cloud. It's not the Salesforce cloud this time, this is the remote Git. So we're just going to click on that. Little progress bar up the top here, hopefully you can see that. And we're done. And again, flip back to GitHub. We can now see there are 2 commits. If we click on the 2 commits, we can see our initial commit and then our second commit of adding that field. Now if we click on the little unique ID for that commit over here, we'll see something quite interesting. We'll see details of what was added. The little plus symbols represent a line that's been added and the fact that it's coloured in green. We're going to do one more change on this just to demonstrate one more feature. So we are going to go back to our org. No, we're not. We're going to go there. There we go. And we're going to find our Git name field. Edit that. And we're going to change our field label. Git name 2. And save that. Yes, we know it affects merge templates. That's fine. Okay, so again, same cycle. And in fact, with this one, we can actually just pull that single individual field and retrieve. It pulls that from our Salesforce instance. And oh, as if by magic, the label is now Git name 2. And again, we want to put that correction into Git. We click to the Git tab and refresh. It detects the change. If you click on that file where it detects the change, you'll notice something interesting. You'll get a side-by-side comparison of the old on the left and the new on the right. And as I said, Git works with pluses and minuses, so additions and removals from your file. So on the left, we have the removal of the old Git name label with a minus coloured in red, and we have the addition of Git name 2 with a plus coloured in green. So we can very easily confirm that that is definitely the change we want to make. If we're happy with that, stage the changes, we can hit the plus icon here. And here, add our commit message, updated label. So you noticed earlier that I was doing Control and Enter to commit that. We can also equally just hit this tick. The nice thing about Visual Studio Code is whether you're used to key presses or whether you're used to mouse clicks, it's much easier to find. There's usually a few ways of doing that. So again, here we can see synchronize the changes. Now, there's two little arrows down here. See if I can zoom that up a bit for you. So, 0 with a down pointed arrow. There are no changes that we need to pull down from Git. There is one change that we need to push up to Git. So, click the button. We do the push and pull to synchronize everything. Our little slidey progress is finished. Back to Git. And we're going to look for that latest commit. We have 3 commits as expected. There's our updated label. And there we can see exactly what we saw in VS Code. We can see the removal of the Git name label and the addition of the Git name 2 label. Same conventions, the pluses and the minuses and the reds and the greens. Now, what we can also do is we can add comments to that. So we can add comments after the fact so that anybody saying, oh, you know, this thing has changed, when was it changed, who was it changed, we can say, okay, label was incorrect, so I fixed it. Okay, this all adds in to the ability to sort of track and audit changes and keep a tab on how changes happened, why changes happened. We tend to have check-ins associated with Jira numbers. If you're familiar with Jira, it's how you raise user stories in a very agile sprint-based development thing. And a lot of our Jira stories are admin tasks. They're not all code-based, pure development pieces. It could be a workflow, it could be a validation rule. These things all still need to go through source control. So very easily you can see contextually where change was made. So flipping back to our slide deck, a quick recap of what we've seen there. So we've seen that we're working with Visual Studio Code and the Salesforce command line interface. Don't let the fact that it's a command line interface scare you, because as we've seen, much of it is wrapped up in the Visual Studio Code extensions, and that allows us to have nice little menus and mouse clicks and buttons, and it really sort of guides us through the process nicely. We've seen Git and GitHub, so a means of storing the changes and kind of having those kind of captured and safeguarded locally, and then that local copy replicated up to GitHub. We've seen the process of how we move change between our org and Git via Visual Studio Code. So we check the code out of our org, we make the changes, and then we commit it back up into GitHub. Now there is much more complexity to Git beneath the surface. Some terms to be aware of for later research are branching, where we take a split of the main Git and we make our little sort of feature-based changes and we merge those back in. That's slightly more complex than I'm going to include in the scope of today's session. But it's definitely a useful feature in larger organisations. And then potentially there with that process, you may have what are called merge conflicts, whereby you could have two admins, two developers that have changed the same items in parallel, and you just need to kind of reconcile the two together to work out, which set of changes you want to keep, which is the correct, which is the aggregated set of changes that effectively will make it into your code branch or your Git branch. Again, both Git and Visual Studio Code's Git integration have very, very good tools for managing that. Again, something for potentially a future session, but it's worth doing a little bit of research on what that's about. Speaking of research, here's some great places to do just that. So, of course, Trailhead. Trailhead has a Git and GitHub Basics module, which is very good, and will allow you to sort of get up and running with that. Again, don't be put off by the fact that Git is primarily used for code, as we've seen. We can also use it for admin, config, structure. Atlassian, the company behind Bitbucket, which is a competitor of GitHub, they have some very good Git tutorials on their website. And because Git is a free and open source tool, and it's available to Bitbucket, it's available to GitHub, the tutorials are actually quite product agnostic. They're not necessarily too heavily tied to Bitbucket. There will be a few references, but most of the concepts that you see in there, you'll be able to apply to GitHub or to any other provider. Your company may even have its own centralized Git server. And finally, understanding the power of metadata. I should have probably short linked that link, but again, if you go to Trailhead and search for the power of metadata, you'll find a really good example of how to get the best out of metadata, which is the description of our configuration that we used to move in and out of Git. So hopefully that's given you a good overview of how we can use source control and specifically Git from an admin perspective. It's not all about code. It's just a means of moving change between environments and keeping it safe and tracking those changes. I hope that's been useful to you. Thanks.